Okay, ladies and gentlemen, hopefully you watched my previous video, Introduction to Completing the Square. And we're going to take it one step further now. Okay, one step further. So, here is problem 9 from a recent worksheet. And hopefully you notice I have a quadratic right here in standard form. It's equal to 0. Now, we could solve this using the quadratic formula. We could use a quadratic formula, but I want to show you another fairly cool way to solve this. Notice how we have an even number 12 there, correct? So let's just manipulate the equation a little bit. Let's take r squared plus 12r, and let's take the minus 85 and add 85 to both sides. Again, I'm adding 85 to both sides, and I'm going to leave a little space, okay? I left a little space right here. Notice that? I left a little space there. But, in other words, I'm going to bring the 85 to the right side, okay? And I left this space right there, guys, for a reason. I'm going to complete the square. So, if you remember my last video, I showed you how this 12r is really 6 plus 6, right? In other words, 12 divided by 2 is 6. So, how did we get the number here? Didn't we add 6 squared? And 6 squared is 36, isn't it? So I'm going to add 36 there and add 36 over there. So what did that accomplish? Well, this right now, guys, is a perfect square, right? Is it not r plus 6 squared now? Equal, and this right here, let's just add that together, is 121. So, if you don't know how to solve a perfect square now, guys, hopefully look at my resulting equation. Could I not take the square root here and square root there? I can square root both sides, correct? And the square root, remember, is the inverse of a square power. So it cancels out that square power. They cancel each other out, actually. So the square root is gone because of the square power. And notice I'm left with r plus 6 equal to, well, what's the square root of 121? Well, that's positive, but also negative 11. And hopefully you remember from a previous video we talked about square roots now having two answers. We have the positive answer and a negative answer, right? Because remember, we know 11 times 11 is 121, right? But we also have to agree negative 11 times negative 11 is also a positive 121. Hence, that's why we have two answers now, the positive as well as the negative answer. Okay, so can we solve for r right now, guys? How about if we minus 6 both sides? And don't we now have r, with the 6 gone, equal to a negative 6 plus or minus 11? And let's go ahead and finish it up. Isn't negative 6 plus 11 positive 5? Isn't negative 6 minus 11 negative 17? Yeah. Guess what, guys? We just solved it using completing the square. Here are my two answers that we came up with. They are my zeros of my equation. They're also called our roots. They're also called the x-intercepts. Remember, those three words mean the same thing, basically. They all refer to the x-intercept or the numbers that make it 0. Okay? So pause the video and study this completing the square process, please. Okay, so let's move on to one more problem. So notice this one, guys. Not only do I have standard form here, but I also have an extra number here, but no big deal, because hopefully you realize I'm going to add 21 to both sides anyways. All right, I'm going to get rid of all my constant numbers. because that's the first thing we got to do to complete the square properly. So notice our result is k squared, right, plus 6k, that's 6k right there. We know 21 minus 21 is 0. I'm going to leave a little space here again, equal to, and 21 minus 6 is 15. Okay, so now what? Well, can't we complete the square? Because 6 right here is really 3 plus 3, right? So if I do 3 squared, I know I'm going to add 9. And don't forget, I got to add 9 to the other side. And I'm on my way. So pause the video if you need to and think about what I just did. Okay, so why the hell did I do that again? Is because right here, notice that's k plus 3 squared equal to, and this right here, of course, is 24. Solving directly for the squared right here, how about if we do a square root to get rid of it again, and square root to 24? The square root and the square power again cancel each other out. I'm left with k plus 3 equal to plus or minus the square root of 24. Unfortunately, we can't make that into a whole number or integer, but wait a minute, we better remember to simplify it at the end. But let's finish the problem up. So to solve for k right here, would I not normally minus 3 both sides? And my end result, I'm going to go to the top right of the screen, guys, is I know k is going to equal negative 3 plus or minus the square root of 24. And that means I have negative 3 plus the square root of 24 is one answer. Negative 3 minus the square root of 24 as my second answer. And so I'm basically done. But one other thing I could do, guys, is couldn't I simplify the 24s? Isn't 24 4 times 6, 2 times 3, or sorry, 2 times 2, 2 times 3 is 6, right? And remember, with the square root, 2 square roots makes a real number. So hopefully you agree my final result is going to be negative 3 plus 2, the 2 came from there, square root of 6, and of course negative 3 minus 2, square root of 6. Again, these are my roots, right? These are my zeros, my x-intercepts. Okay, guys, so pause the video again. So, guys, hopefully this kind of makes sense. Again, this is one of the videos where you need to watch it more than one time. You need to study it. You need to make notes out of it, especially if you're one of my avid students. Please make notes out of this and study it. Make sure you understand the process of completing the square. So until next time, bye.